A very good morning to all the participants of the workshop Biotechnological Advances in Research 2020/2020. Today we have our esteemed speaker, Dr. Saroj Kumar Viswas. He is an assistant professor in Computer Science and Engineering Department. Saroj Kumar Viswas, NIT Silchar since 2010. His research field includes machine learning, artificial intelligence, and their applications. He has 4 PhD scholars presently doing their PhD, and 2 has completed and submitted their thesis. He has completed 1 DEITY sponsored R&D project and currently runs 1 NPIU World Bank sponsored R&D project. He has published total 36 international journals, including 20 SCI indexed unpaid journal in various reputed publications, housed worldwide, including Elsevier, IET, Springer, World Scientific, etc. His total publication is more than 70. So I welcome our esteemed speaker, Dr. Saroj Kumar Viswas, to deliver his talk for today. Over to you, sir.
My presentation is visible or not?
Yes, sir, it is perfectly visible.
So first of all, I would like to thank to the coordinators and other organizers for inviting me for this lecture. My lecture, wait, let me check. The topic is foundation of machine learning.
May I interrupt for a bit? Sir, it will be kind enough if you can make it in a presentation mode because we can see all the side pens as well. Presentation mode.
Okay, fine. And now it's okay?
Yes, sir. Yes.
So the topic of this presentation is foundation of machine learning for biomedical engineering. So I'm going to talk about artificial intelligence and how artificial intelligence is related to machine learning and how we can make a machine learning model. Then those machine learning model, how can be used in, say, medical applications. So the first slide, I have what is artificial intelligence. Nowadays, this term is very much popular to everybody. Everybody knows about this term. But unfortunately, there is no universal definitions for this artificial intelligence. Different scientists define it different ways, but there is no unified way and universally accepted definition for artificial intelligence. But as we are working in artificial intelligence, but at least we must have the boundary line for the artificial intelligence so that if somebody is working in AI, they can understand that I'm working really in AI, or if somebody had implemented something, then they can understand we have implemented some AI system. That's why here the objective is to give a boundary line. And if we give the boundary line, it says that AI is the study of how to make computers do things like human beings. So the objective is to make the computers doing the things like human beings. If we can do this thing, then we can say this is artificial intelligence. In the second slide, why then artificial intelligence can in computer science, in electrical, in mathematics? That's the question. If we see the power of the computer, the computer overpowers human beings in many aspects, and speed, storage capacity, doing repeated works, and remembering the things. For an example, if we store something in computers 10 years back, now if we open the document, we can see exactly the content what we had say stored earlier or 10 years back. But in human beings, if we give something, right, say 1 month back, if we tell something, some story, then if we ask the person, tell me exactly the story what I told you, then there can be certain kind of missing, I think. So in that sense, in sense of remembering, storage capacity, and other parameters, we cannot compare with human computers. Computer overpowers us. But there is one concern in the computer scientists, that is, computer doesn't have common sense reasoning. For an example, if we give one mathematical series like this, 2, 9, 28, 65. So this is 1 cube plus 1, this is 2 cube plus 1, 3 cube plus 1, 4 cube plus 1. So if we see, we can understand. So it is the foundation of this series is like that. But in computer, if you don't have any artificially intelligent software or say programming model, then the computer cannot solve it. So this is a kind of common sense we can apply whenever we see certain problem. If the problems require say a certain kind of common sense, we human beings can apply. For an example, when we drive a car, if we get a turn, generally we go slow. We know there can be problem, but can we make the car? Because nowadays there is a trend that we can make automatic car vehicles. So can we make that vehicle whenever it gets some obstacle, some turn, so that the vehicles can go slow? These are actually common sense. So if we can incorporate common sense in computer in such a way so that it can think like a human beings, then we can say this is artificial intelligence. And this is the objective of artificial intelligence, actually. Now the term comes here, just AI and heuristic search. But my objective is not here to talk about too much about AI techniques. Here the objective is to correlate the heuristic search and AI, means how heuristic search is important for AI. That's my objective. So AI problems can be solved using AI techniques. There can be different kind of AI techniques, especially if we talk about heuristic search. This is very much useful in AI problem solving. So now, if we talk about some heuristic technique, then the most popular is the optimization algorithm. Now, in my next slide, my endeavor is to show the efficacy of optimization technique in problem solving, especially in AI problem solving. So how we can do? So looking at one example, here I have one example. And this example is a very simple example, that is traveling salesman example. This is very well-known example. So the problem says we have 4 cities, C1, C2, C3, and C4. The objective of salesman is to touch all the cities once with minimal cost. This is the problem, and this problem is called traveling salesman problem. And you can see here some values are given here. These values are talking about the cost. If you go from C1 to C1, then the cost is 0. If you go from C1 to C2, then the cost is 2. C1 to C3, the cost is 5. C1 to C4, the cost is 7. In that way, the values are given here. Our objective is to traverse all the cities with minimal cost. That's the problem. So now if you start to solve the problem, how we can start? We can start from any cities. So for this problem, we started the journey from C1. So we start from C1. How many options we have? We have 3 options. C1, C2, C3, and C2. And now from C2 again, from C2 we have 2 options still. So C3, C4. Similarly from C3 we have C2, C4. Similarly from C4 we have C2, C3. Now again from here we have to traverse. So this is C4, C3, C4, like that. And the problem says that we need to touch all the cities, and again we come back to the same city as we started the journey from C1, so that we have to come back to C1. So now this is C1. So now if we see this problem, actually in this problem, how many paths is generated? This is one path. The path is C1, C2, C3, C4, C1. This is one possible path. And again here, this is the second possible path. In that way, if we calculate all the possible paths, then the number of paths is 6. This is 6 paths are there. So now if our objective is to find the minimal path, then obviously we have to search all the paths. Then we can say one of them is the best. So as the number of cities is 4, that's why the solution looks very simple. But keep in mind, if we find this solution mathematically, then how it costs? It costs like this, because we have say 4 paths, 4 cities. If we have 4 cities, then how many paths we created? 6 paths. Now, if we see mathematically this one, then we can see that this actually the growth rate of this path, the growth rate of this solution actually represented by factorial n minus 1. This is n minus 1 because we had 4 minus 1, that is 3, factorial 3. That's why the total number of paths is 6. So as the number of cities is very small, it looks very small. But if you see the growth rate, there's a time complexity of the algorithm. Now the time complexity of the algorithm can be represented order of factorial n. This is the time of complexity. And keep in mind, this kind of problem is called NPhard problem, because this problem cannot be solved in a non-deterministic machine with polynomial time. So these are the NPhard problem. And this kind of problem also called combinatorial explosive problem. Combinatorial explosive problem. And this problem, the nature of this problem is intractable. Means we cannot track. It means what? It means we can give to solve the problem now. If the number of cities is very high, then we can get the solution after our death. So after 90 years, after 100 years, we can get like that. So if we get the solution after our death, then this solution doesn't have any impact. So because the solution is the NP-hard solution, so this problem cannot be solved. Then here, if we apply one heuristic such algorithm, say the heuristic is the nearest neighbor heuristic, then how many paths or how many areas we need to explore looking from here? Because now we're looking nearest neighbor. So we can start from here. So which one is the nearest? This is C2 is the nearest. And keep in mind, from here, we explore this also, right? We have to explore all the paths, only then we can find this one is the minimum. Similarly, we can start from here. And we're looking, we have to search both paths. Then we can find that this one is the minimum. So from here, there is no choice. There's simply here, then simply here. So this is the minimal path. Now, if you want to implement this one in, say, programs or algorithmically, if we want to write, then we can write these programs by a nested loop, because we are coming here. So n number of nodes, we need to how many? 4 nodes. How many nodes we have to traverse? This is 1, 2, 3, and 4. But keep in mind, each time we need to traverse how many? n-1 path. n-1 here, n-1 here, n-1, n-1, right? So if we represent the time complexity, if we apply the nearest neighbor heuristic search, then the time complexity can be represented order of n square. So this order of n square is solvable in polynomial time. So this is tractable problem. For an example, if we have 10 number of cities or 11 number of cities, if we apply this one, this is the exhaustive search, the total number of paths we need to traverse, it is more than 36 lakh. And here it is only around 100 paths, only 100 edges we need to, 100 possibilities we need to explore here. So whenever we apply some heuristic search algorithm or optimization algorithm, this NP-hard problem can be solved. But one concern is here, whenever we apply some heuristic search algorithm, it doesn't guarantee to produce the optimal solution, but it guarantees to produce some good solutions. So whatever solution we'll have, that solutions can work on the problem. So that's why actually we use optimization algorithm. So whenever we work on optimization, so our concerns will be here. This one should be our concern, where how much is the time complexity. So it should not be too much complex so that the time complexity becomes higher and higher. Because even if we can have, say, NP-hard problem, if the sample size is very small, means the input is very small, then NP-hard problem is also solvable. But keep in mind, whenever the sample size increases, the NP-hard problem cannot be solved. So that's why actually in computer science, or you can say in AI, the optimization algorithms is very much useful and inhospitable to solve AI problem. Now, in the next slide that I'm coming to, find the correlation between AI and machine learning. Whenever we say AI, people say this is machine learning, but not exactly that. So just coming to clarify that one. So here we have written rule-based expert system. Expert system is one thing which produces some decisions automatically by a computer. Then we can say this is expert system. Now say we implemented one expert system, right? The figures are not exact actually, right? Just only to give the example, we have taken these figures. So we made this example here. So this example says that whether somebody is suffering from diabetes or not. Now we set certain kind of constraint here. These are the constraint. This is the constraint. This is the constraint. This is the constraint. If this constraint satisfies, then we can say yes, diabetes is there. If this constraint satisfies, then we can say yes, diabetes is there. If this is the constraint, then we can say no. Now the case. if these constraints are established by some experienced doctor or experienced scientist without performing or without doing analysis of the historical data or without using any machine learning algorithm, then we can say this is an automatic system. This is an expert system. But this is the expert system, and this expert system is called AI system. This is AI system but without machine learning. So those things also we can channel, we can find out those characteristics also using some machine learning. So whenever we find this relationship using the analysis of past historical data using some machine learning algorithm, then we can say this is the AI system using some machine learning. So now my endeavor is here to say that all the expert systems are not machine learning based. Whenever we say AI is not necessarily machine learning system. So this kind of system we can say AI, but this is not machine learning. So we can conclude from here that machine learning is a subset of AI. Now coming here, then why machine learning? Because nowadays people are talking about machine learning. So machine learning, because in many cases, we can see there are some algorithms. If we have some defined tasks, for those tasks, algorithms are available. If we can solve this problem using some high-level algorithm, for an example, sorting problem, so sorting numbers, there are a number of sorting algorithms. So we can sort using those algorithms. In such cases, so machine learning is not required because already we know the algorithms are available. But we can have certain tasks, certain problems. Those problems cannot have readily available algorithms. There is no predefined algorithms. So if we don't have predefined algorithm, then to solve those problems, the machine learning is used. For an example here, we can have the emails. Some emails can be spam emails, some emails can be legitimate emails. So whenever the emails come, we cannot understand. So if we have the historical information, if we have say 1,000 and 1,000 say emails, and out of 1,000 and 1,000 emails, if we can understand some are say spam and some are legitimate email, we cannot. There is no particular algorithm to solve this one. So when this past historical data is available, we can use some machine learning algorithms. The machine learning algorithm will say will be trained on that because the machine learning algorithm will try to find out certain kind of patterns from there. If this pattern is there, then we can say this is a spam. If this pattern is there, then we can say this is a legitimate email. So this kind of learning is done over the past historical information, so past data. So there is no particular algorithm for that. Even these spam mail detections algorithms, it varies from time to time. It varies from person to person. Because we can see in your email ID, if you specify some email as a spam, so next onwards, the machine is trained in such a way so that this email will not come as legitimate email to your email box. So in such a case, actually, the machine learning is used. Now, if you want to define what is machine learning, so definition of the machine learning is this. Machine learning is programming computers to optimize a performance criteria using example data or past data. It should be past data. So if we define machine learning, two criteria is there. Then we can say this is machine learning. So we can have huge historical information or the past information. If we have huge past information, if some algorithm is applied there, then we can say, yes, we're doing machine learning. At the same time, the second criteria is whenever we use machine learning algorithm, it try to find out the optimal value of the model parameters. Because whenever we use certain kind of classifiers, the classifiers is having certain kind of parameters. If we can find the optimal values of these parameters, then we can say that our classifier is best. Our objective is to find the optimal value of those parameters. For an example, we can talk about the neural network. It is well known to everybody. Here is the parameter is the width. So our objective is to find the optimal width. This is the parameter. Similarly, we can have different kind of classifiers. In different kind of classifier, the model parameters are different. So in machine learning, two objectives are there. From this statistical information, we have to find the optimal values. Means we have to try to find the optimal values of those model parameters. So if we do these two kind of things, then we can say this is machine learning simply. Now here, what are the examples of machine learning applications? Nowadays, we can see everywhere the application of machine learning. So now, if I categorize the applications of the machine learning, then it can be categorized in that way. The first one is learning association, and here classification. Then we have regression, not regression, sorry, this is regression. Then here's clustering, and also we can have, say, reinforcement learning. It is missed here. Now, under each categories, there can be number of applications. You can apply in, say, business market, you can apply in a financial field, you can apply in, say, medical diagnosis, in different kind of different applications we can apply machine learning. Just giving a small example here. So here, this is learning association. It tries to find certain kind of relations between two items. It finds the conditional probability. And now say, from a big supermarket, we found a conditional probability, and this is the conditional probability. The P probability of, say, this is probability of chips given beer, and this is equal to 0.7. It says that whenever some buyer buys beer, there is a possibility that the buyer will buy chips also 0.7. So if we analyze the statistical data of the supermarket, and if we can find this kind of relation, this relation is really very much important and significant for the supermarket. Because whenever the supermarket wants to make its stock, so whenever the supermarket buys 100 bottle beer, at the same time it buys 70 packets of chips, so that in future there won't be any mismatch among the items. So it will improve the business processing or marketing strategy in that way. And now if we talk about classification, there are a number of applications in classifications. One application I'm just telling here, whenever we do application in image processing, so some tumor can be there, some tumor can be malicious tumor, some tumor can be benign tumor. What generally we do, we take the pictures, and from the picture we generally, from the image, we extract number of features from there, we analyze it, and then we classify whether it belongs to, whether the tumor is cancerous or not. So whenever we can classify the tumor is cancerous, then the patient has to consult with the doctors or has to take therapy. So in that case, in this way, the machine learning can be used. This is the application of image processing. So machine learning can be used for classification also. In that way, there are a number of applications here I'm not going to talk about, but here I want to highlight the differences between classification and regressions. Whenever we have discrete data, 1, 2, 3, 4, like kind data, then we can say this is classification. So whenever our, say, predicted value is a continuous value, then we can say that is the regression problem actually. Now, the classification of ML algorithm, because we are having number of algorithms, ML algorithms, to solve number of problems. Now, based on the behavior, how the machine learning algorithm is trained, based on that, the machine learning algorithm can be categorized into 3 categories. These categories are supervised learning, unsupervised learning, or reinforcement learning. And that is within supervised learning, these are the applications, classifications, regression. And here, clustering, association, and reinforcement is the Q learning. So now I'm going to talk about briefly what is supervised, what is unsupervised, what is reinforcement learning. So here, the supervised learning is a learning where the training data, the statistical data is having the levels. See here, this is the level. This is the dependent parameter. If the dependent parameter is there, means the class is there, and these are the independent parameter. If we have this kind of historical data, and if we train a model, then we can say this is supervised learning, because some supervisor is there, whether the output is yes, no, or some kind of particular output it can give. So it can be particular output if we talk about, say, regression problem. If we talk about, say, classification, it can be 1, 2, 3, 4, 5, like that. So if the data is like that, then we can say this is supervised learning. Now, these are the very popular supervised algorithms in machine learning: name-based, decision tree, support vector machine, artificial neural network, KNN. These are very much popular, and there are many more supervised algorithms available in machine learning algorithms. Now, the unsupervised, whenever I talk about unsupervised learning, means we don't have the supervisor, we don't have the label data. But now we can see this data. This is the pattern X1. The pattern X1 is having its attribute values, the attribute A1, A2, A3, but it doesn't have any output, whether it belongs to positive, negative, or whatever it is. It doesn't have. Similarly here, X2, again, it doesn't have. It has only the values, only the values, only the values. But keep in mind, in historical data, whenever we have patterns, within the pattern, there is some regularities, there is some interrelationships. The objective of unsupervised learning is to find these regularities and this interrelationship. Using this interrelationship, it can do certain kind of tasks, and which is really very much significant in technical studies or in different kind of applications. I'm not going to talk about the application. There are number of applications, 100 applications. Now, how we can find, for an example, so our objective is to make the clusters. Cluster in the sense, if x1, x2, x3, they are very much similar, we'll keep x1, x2, x3 together. If x4, x5, they are very much similar, then we can keep x4 and x5 together. But how we can do? Then we have to measure whether they're similar or not. To measure similarity, we have different kind of distances. So one of the distance is Euclidean distance. Then we have also CD-block distance. But keep in mind, all those distances comes from one equation, and that equation is called Minkowski distance. Right? This is the equation, right? And here, if we give the value of r is 1, then it becomes a CD-block distance. If we give 2, then it becomes Euclidean distance. Now we can increase the value of r. It can be 3, it can be 4, it can be 5. But keep in mind, even if you're changing the values of r, the output actually doesn't change. So therefore, it is wiser to use Euclidean distance because the value of r is only 2 here. Now the question is, why not CD-block? In CD-block, the value of r is 1. But keep in mind, if we have very small difference, then a small difference is less focused if we have a CD-block distance. If we have Euclidean distance, if the difference is very small, still the difference is focused too much. That's why Euclidean distance is well accepted. So there are also other distance similarities, Pearson correlations, and many distance similarities are there. We're not talking about that. So using those distance similarities, if you find that x1, x2, x3, they are similar, so that we can keep all the patterns together, and here all the patterns together. And whenever the patterns are kept in a cluster, it is believed that based on the similarity, now we can take different kind of decisions. An application decision, it can be, say, technical decision. We can take many decisions here. And now we talk about some of the algorithms, unsupervised algorithms. Then we can say this K-means. This is one of the clustering algorithms. Coherent self-organizing map. To some extent, this nearest neighbor is also unsupervised. It depends on how we are using nearest neighbor. Then we have the reinforcement learning. What is that actually? In reinforcement learning, we don't have any level data, but still master is there. Supervisor is there. So what kind of supervisor here? So we can have a pattern. Supervisor means no specific value is there based on the output taken by the agent or by the system for this pattern. Some values can be rewarded or some values can be penalized. If the systems goes in the right direction, then some reward would be given to encourage the system. You go ahead. You are in the right direction. If the system takes some steps and the step is not right, then some kind of penalty function is associated so that the system can understand we are not in the right direction. So here one thing can be pointed out. So this reward and penalty function for those, the equation is not defined. No particular equation is there. Now in different applications, we can have different kind of equations. By this equation, we can give some reward point, or we can have certain kinds of penalty equation. By that, we can give some penalty function. So again, you can do research on that. So if we talk about some of the algorithms which follow reinforcement learning, and these are random Boltzmann machines, and deep belief neural networks. These are the examples algorithm. There are also others. One example I'm going to tell you. If you talk about the movement of a robot, the movement of a robot means what? The robot will have a source destination, and the robot will have a source, and one is a destination. From source to destinations, it may have number of nodes, number of edges in the path. So whenever the robot goes, if the robot goes in the right direction, then we can say some reward can be awarded. If the robot goes in the wrong direction, some kind of penalty functions can be given, penalized. The value can be penalized so that the robot can understand or can learn from the environment. So this kind of learning is called reinforcement learning. So already talked about the supervised, unsupervised, reinforcement learning. So classification is one of the supervised learning. So here my individual is, if you want to make once a classification model, then what kind of things we need to follow so that we can make it a robust model. So if you want to make it a classification model, initially you must have say data set. This is level data set. Then we can do number of pre-processing tasks here. And these pre-processing tasks includes data cleaning, class imbalance, means this is treatment of class imbalance problem, then feature selection. And then we can choose some of the classifiers to train the model. We're coming to discuss briefly what are those and what are the problems, what are the techniques available for that. So this is the first one. First one is the data cleaning. Now the question, what is the importance of data cleaning? Data cleaning improves the quality of the training data. And it's true that if your quality of the training data is very nice and very good, then the performance of the classifier will be very good. So what is the data cleaning problems? Now in the data cleaning problem, if you see, there are two kinds of methods. One is called deletion, another one is called imputations. So what are those actually? So going to discuss about. Now talking about the deletion. In deletion, again, we are having two methods. One is called deleting rows. There are many more methods, but here just I'm going to focus two methods, deleting rows and deleting columns. So now coming deleting rows. In deleting rows, what happens? We're talking about the data cleaning part. Data cleaning means the missing values actually. So now if we see this database, in this database, this part is not there. This value is not here. So some kind of data cleaning is required, or this is because one missing value is here. So now if now follow the deletion approach, not data imputation, deletion. And in deletions, we have two approaches. One is deleting rows, another one is deleting columns. So simply we can delete this whole rows from here. So if we delete this one, now the training data becomes like this. Deleting columns. So now we can have the training data like this. And here it is wiser to drop the whole column because the number of missing values are there. So we can drop it. So if we drop it, then the training pattern becomes like that. The training, this is the training values, training data you can see. This hard value is dropped here. So now this is the refined data after data cleaning part. Now if we use a data imputation, for example, our database size is very small. So if it is small, and if you do a data deletion kind of thing, then the size of the database becomes more reduced, more or less. And one thing should be pointed out here, if the database size is more reduced and less, the generalization capability of the classifier becomes less actually. So that's why the objective is always to increase the number of samples in the historical data. That should be the objective during training. So now, say this is the missing values. So now, if this is the missing values, if we want to treat this one by say data imputations, data imputation means what? Synthetically, we try to generate some data so that we can give some values here, and then this value can be given to the training for training. In data imputations, again, the methods can be categorized. So we didn't show here all the categories, but in data imputation, there are some techniques. These techniques are used generally for data imputations: mean, median, mode, linear interpolations, linear regressions, KNN method, and there can be number of machine learning techniques to generate the synthetic data. So people, those who are interested to do research in say data science, they can think also about this one, how we can devise new algorithms so that the data imputations can be very good. Even if data imputation is not desirable in training, because whenever you are synthesizing the data, means you are artificially creating the data, and that data doesn't have the real impact. So if we want to impute the data using some mean, then we need to take all the values, these, and we can find the mean. This mean can be given here. So this is one of the approach by which we can impute the data. Then say this is the missing value, and the values are categorical values. Earlier the values were say continuous value. Now say these are the categorical values. So if these are the categorical values, to find out this one, we can use say k nearest neighbor. And now here the value of k is say 4. 4 is taken. So we need to take 4 nearest neighbor. Then we can check the mode of that, the majority of voting that is. So y, we have what? Y, n, y, y. So if we apply majority of putting, then this value would be y. So y can be given here. So in that way, we can impute the data. So but the conclusion is here that data imputation is not desirable in machine learning. So after that, the next one that comes, that is called data imbalance problem, that is called class imbalance problem. So what is actually the class imbalance problem? First of all, you need to understand. It says that in the training set, if we have the two classes, one's the black dots, another one's the blue dots. So black dots overpowers blue dots because the number of black dots outperforms the number of blue dots. So this kind of problem is called data imbalance problem or class imbalance problem because this class is more than this one. So what is the problem? If we have this kind of data, the problem is that it biases towards the majority class. Because if we have this kind of database and if one classifier is trained here, so whenever some new pattern or the test pattern will come, then the tendency of the classifier would be to assign that test pattern to the majority class. That's why it is written here, biases towards the majority class. That's the problem. So if we have the class imbalance problem, then we need to remove it. Some kind of solutions will be given here. Only then the training can be very good. One question may be here. So when this data imbalance problems comes in considerations, especially in medical fields, these class imbalance problems occurs. Think about whenever somebody is gone for say medical diagnosis. Most of the cases, so the positive patient is less than the negative patients. So the number of negative patients is always more than the positive. So if we keep records of all the patients and if we make once a database, the historical database, then the nature of the database will be class imbalance. So whenever we have such kind of problem, it has to be treated. Only then we can get the robust classifier, a reliable classifier. Now to treat this class imbalance problem, we have number of solutions here. The solutions are categorized into three categories. And these categories are sampling solutions, then algorithmic solutions, then ensembling solutions. What is sampling solution actually? Sampling solution means either we can increase the data or we can decrease the data. So based on that, this sampling technique is categorized into two categories. One is undersampling, another one is oversampling. Undersampling means we need to reduce the majority classes. And to reduce majority classes, we are having number of algorithms. Here, this is RAS, this is random undersampling, format link based undersampling, condensed nearest neighbor undersampling, and there are many more. And this is also hot topic in data science. If somebody wants to work in data science, they can look here also. Then you need to see the state-of-art techniques which are available for undersampling. So we can undersample. By undersampling, we can balance the data set. Then this data set can be given to the classifier to be trained. And now if you follow oversampling, then what happens? In oversampling, what actually we do, we increases the minority class instances. Here it is written majority. Sorry, it is a minority actually. Sorry, this is a minority. Our objective is to increase the minority class instances so that the database can be balanced. Again, there are a number of methods for this one. The methods are ROS. ROS means random oversampling. Using random oversampling, we can randomly generate the synthetic patterns. And there are some state-of-art random oversampling techniques. And these techniques are smooth. Then we have borderline smooth, step level smooth. And these are the state-of-art in oversampling. So again, if somebody is interested in workings, the data science, they can look here. Now the question, what is the problem with the undersampling? The problem is that whenever we remove certain data from the majority classes, there can be a chance that we are losing some information from here. We can have certain good information in the majority classes as you are removing the attributes, patterns. So some meaningful information can be removed from here. So what is the problem of oversampling? Oversampling is whenever we are putting here new informations, new patterns, it means what we're going to overfit the model. So both are having certain kind of problems. So after that, there is another kind of solution that is called algorithmic solution. What is algorithmic solutions? in that solution, it says that we need to change the misclassification cost. The value of the misclassification cost means the cost function we need to change. The cost function for the minority class should be increased. Think here, when the classifier is trained, all the patterns comes here, once, say, the majority pattern, there's a 10 majority patterns, and each 10 majority patterns will come to the classifier. And here said this is there is only 5 minority patterns. So 5 times it will come to train the classifier. So whenever it is trained, some kind of misclassification happens, then it gives some kind of cost function. So for an example, here the cost function is established as 1. Here it is set as 2. So if it gives 1, if it gives 10 times, then we can say the cost change of cost functions due to this majority class is 10. And now here, if we increase the cost function for the minority class as 2, then even if the classifier is trained by 10 patterns, or also 5, so using say 5 patterns 5 times, then we can say the total number of cost functions which is associated here as 10, because each time the cost function is 2. In that way, we can assign the cost function that is called cost function misclassification cost. But the problem is here, how we can define the misclassification cost, whether it can be 0.2, 0.5, 0.8, is very difficult to say beforehand. Before training, we cannot say actually, so that we can establish some kind of equation here by looking the examples, by looking the number of training patterns and the classes. If we can devise one equation, then we can give this cost function to this minority class during the training. So here also we have the scope of work, but keep in mind it's very difficult to apply this algorithm. And after that, we're having ensembling technique. Ensembling what? Already we know the meaning of ensembling is whenever we combine different classifiers together, we fuse together, then we can say it becomes ensemble classifier. So there is a huge trend of ensemble learning nowadays. So we can have certain kind of ensembling technique, and with the ensembling technique, if we apply either sampling or say algorithmic, then it becomes ensembling technique for treatment of class imbalance data. Some of the ensembling techniques which are available for the treatment of class imbalance problems, a small boost, rush boost. So these are the state of art. So if you want to work, you can see here so that you can augment our work. So here we have seen the necessity of the class imbalance. So keep in mind, whenever you're going to make one model, the treatment of the class imbalance is very important. So most of the cases generally we don't do. But in real, if you want to make some real life applications, we need to consider this concern and this issue. Only then we can make once a robust and reliable classifier. After that, we're having the feature selection. This is feature selection. So in most of the cases, so all of the features which are available in the problem may not be useful for the training of the data. So if they are not useful for the training of the data, then they should not be used. They should not be kept in the training samples. So if we do the feature selections kind of thing or feature removal kind of things, then what are the importance? What are the benefits we can get? So we can get 2 benefits if we do feature selection. One is it reduces the cost, then it increases the accuracy. How it reduces the cost? So here we have taken a simple example here. So we have 1, 2, 3, and 4 attributes, and say by experimentation it is observed that this attribute is not useful for the training. So this attribute is a relevant attribute, or this attribute is a redundant attribute. So we need to remove this attribute. So whenever we remove this attribute from here, then the amount of information which need to be kept in the computer memory is less. Here the chart is, we have less number of sample here, less number of attributes. That's why it seems that the amount is very less. But keep in mind, whenever we make a model, we can have a million data, and we can have a million say patterns there. And number of attributes can be 40, 50, 60, or even say 20 we can have. So in that cases, if we can remove the 2 attributes from the data set, then the impact of the space of the computer is huge. So it reduces the time complexity. At the same time, it reduces the space complexity because the memory requirement is less. Whenever the size of the information is less, then the algorithm becomes faster. So in that way, it reduces the cost. Now, how it increases the accuracy? So whichever attributes we're having, the attributes say which are removed can be categorized in two categories. One is called redundant, another one is called irrelevant. If there are some irrelevant attributes, if that attribute is removed from here, then it may be observed that the accuracy of the classifier improves. Actually, what happens in machine learning, when we have a limited size of the database, and if we increase the number of attributes, initially, the performance of the classifier increases. But at a certain point, the inclusion of the attribute doesn't improve the accuracy of the classifier, rather decreases the accuracy of the classifier. Because the size of the data set is limited, it's a finite. Generally, in machine learning, it is assumed that if we increase the number of samples, then we can increase the number of attributes. So in that cases, the accuracy is improved. But keep in mind, whatever experimentation we do, we have a limited number of samples. So actually, whenever we have, say, a small database, then using these feature selections, we can reduce the cost of dimensionality. Because in small data set, if we have huge number of attributes, the performance drops. So generally, we use what? We use feature selection. So that some irrelevant attribute can be removed from there, and we can make one a reliable system. So and in this process, it also improves the accuracy of the system. So therefore, the feature selection is required. Now, how we can do the feature selection? There are a number of methods of feature selections. But if you categorize the method, feature selection method, then it can be categorized into two categories. One is called filter method, another one is called refer method. So now I'm not going to categorize, but I'm going to show some of the approaches which can be used for the feature selection. The first one is called, this is the exhaustive search. Then this is branch and bound search, selection of base. And here sequential forward selection, sequential backward selection, sequential floating search. So if we use the exhaustive search algorithm, then there is a chances that the solution growth rate of the solution becomes NPhard. So even if it is the best one, so that we cannot use this exhaustive search algorithm. Then it comes to branch and bound. In branch and bound, we can set some minimum and maximum values. That's why it's called bound. We can set some threshold parameter based on the intermediate results. And then based on this threshold value, we can jump from one branch to another one. That's why this is a branch. That's why it's called branch and bound search. So to some extent, it can reduce the time complexity, but still the time complexity is huge. Then we can use selection of the best individual. The problem is here, it doesn't take the interrelationship between the attributes. Then we come to sequential forward selection and sequential backward selection. These methods are used. But there are also some problems, and this problem is called nesting problem. This one in sequential forward selection, if once one attribute is chosen, later this attribute cannot be dropped. Similarly, in case of sequential backward selection, if once one attribute is dropped, it cannot be taken back in the set. So this kind of problem is called this nesting problem. Now to overcome from the nesting problems, we have here sequential floating forward selection, sequential floating backward selections. This algorithm actually overcome this problem. And again, so based on the situation, what do we want? Based on that, the sequential forward selection and sequential floating forward and sequential floating backward selection can be used. But I don't have time so that I can discuss. These things are very much interesting here. So now, after that, these are the conventional. Whenever we read some books, we get these methods. Now, if you say state of art for the feature selection, there are some new approaches. For an example, we have relief, the new approach. Then relief F, this is the new approach. Then also we have feature score. These are the refer method, and these are state of art in feature selection. So in those approaches nowadays, there is a trend that whenever certain kind of optimization kind of thing is required, the people are using a genetic algorithm, neural network. So now we can conclude as a feature selection, also we can use a genetic algorithm, or we can say evolutionary algorithms, and also we can use neural network there. So whenever we do feature selections, if we have a set of say 1, 2, 3, 4 set of 4 attributes, our objective is to find the optimal subset from there. So in this case, if age is dropped, then this can be the optimal subset of the features: BP rate, heartbeat, and weight. So there is a huge scope in data science if the people are interested to do the research work. So in feature selections, we can work. they can work actually. So after that, one a big question here, that's a big question. So now the pre-processing is done. It is over now. Now we have to apply one of the classifiers to make the model. Now the question, how we can choose the model, how we can choose whether we can use a neural network or say a support vector machine or some other things. That is called the model selection. This model selection is the open challenge to the machine learning community. There is no unified way to select the models. But when we do certain kind of application, we use arbitrarily, yes, neural network, apply neural network. No. So it's a research area that is called model selection. That's really very interesting. Now the question, how we can do model selection? Because it is still open challenge. But you see, there is certain kind of things. If we do data exploration and data visualization, from there we can have idea which kind of classifier can be used to solve the problem. Or how we can use data exploration and data visualizations. For an example, we have a problem. And in the problem, we'll have a supervised problem, and we'll have number of attributes. Now for a particular attribute, we're finding the mean. What is the mean? So we got the mean value, and then we're finding what is the median value. So we're finding the median value. So now we have mean and median. Now, if we observe, there is a big gap between mean and median. It means what? It means there is big fluctuation between the attribute values. So attribute values are not normal. The values are situated in the space in a very scattered way. The values are very scattered. If the values are scattered, then which kind of classifier can be used? It's a question now. So you can answer these questions. If you know the mathematical foundation of all the classifier, only then you can answer. Otherwise, you cannot answer. So you have to know mathematically how the random forest works, how decision tree works, how support vector machine works, how the neural network works. If you know mathematically, only then you can have idea that now the pattern is are situated in the space in very scattered way. So which classifier can be used there? So my experience says whenever the values are in the scattered way, then we need to use the artificial neural network because it is very much powerful in mapping the input-output mapping. And if we see the problem, and in the problem, most of the cases, if we see the values are discrete in nature, so if they are the discrete, then we need to use the decision tree or random forest we can use. So this is possible if you know the mathematical foundations of the classifier. Then after model selections, we need to say train the model, then test the model. What generally we do, the method what we follow, that is called holdout method. Actually, what do we do? 80% used for training, 20% used for testing, or 70% used for training and 30% used for training. This method is called holdout method. But keep in mind, in holdout method, there is some problem because the patterns are not uniformly distributed in the space. They are not uniformly distributed. So if they're not uniformly distributed, so you can take the test pattern from a chunk and now say, oh, all the test patterns are positive. So even if you say your train model is biased totally towards the positive, it's not working properly. Whatever pattern comes, it produces positive always. So as all the test patterns are positive, if you give to the faulty classifiers, the testing accuracy becomes 100%. So that is the problem in the holdout method. This kind of testing is called holdout method. So now to overcome this holdout method, the k-fold cross validation is done. Whenever we have a small size database, generally we do k-fold cross validation. And universally, this 10-fold cross validation is accepted. Now the question, what is this 10-fold cross validation? So looking here, the example. So if you want to do 10-fold cross validation, then whole data set is divided into 10 equal parts. So for better understanding, say we have a data set and data set is having 100 patterns here. So we segregate it and each division contains now 10 patterns. So what we can do in 10-fold cross validations? We take one fold from here. Say the first fold we have taken for the test, that is 91 to 100. This is kept for testing. And the whole is, this is 1 to 90 is used for testing. So also training. So model is now trained and now we can test. Now here, again, it's kept back. So now we are having again training samples, how many? 90. So we have taken this one and say which one? Testing. So now we can train the model using this data set, and using this data partition, we can test the model. In the third iteration, what we can do? We can take this 90% and then we can test this one. And the fourth iterations, we can take this 90%, test by this one, and fifth this, sixth this, seventh this, 8, 9, 10. So what we actually did here? We trained the model with all the patterns by repeating the patterns, and the testing accuracy, whatever we can achieve from here, this accuracy is achieved from all the patterns. Like even if the patterns are not uniformly distributed, still we'll get one unbiased accuracy. That's why generally in machine learning, this tenfold cross-validation is accepted. Whenever you produce a paper or say technical report, it's a good journal, you must have tenfold cross-validation, otherwise it is not accepted. So now the case, if the data set is very small, then which kind of training we need to use? Then another kind of approach can be used, that is called bootstrap sampling. In bootstrap sampling, even if the data sample is very small, we can repeat the data, we can generate number of training samples, then we can train the classifier, and then we can find the classification accuracy. And that methodology is called bootstrap sampling. So these three kinds of methods generally we apply to find the accuracy of the classifier. So train the model. After training, then we need to classify, then we need to evaluate the performance. For the performance evaluations, here we have different kind of measures. So generally, the popular measures, these are recall, precision, accuracy, false negative rate, F measure, AOC curve, MCC, Matthews correlation coefficient. These are the parameters. Using those parameters, we find the accuracy of a classifier. Now to measure these parameters, we need to make a confusion matrix. And I have seen here a confusion matrix of a binary classifiers or binary classification problem. So we have 2 into 2 confusion matrix. If it is a ternary classification or 3-class classification, then we can have 3 into 3 confusion matrix. Using from this matrix, easily we can calculate the recall. Recall means how much it can recall the positive patterns. That is called recall. Precision means what? Whatever positive patterns generate out of all the positive, how precise the result is. So using this equation, we can calculate very easily. And after that, we have the model accuracy. This is the total accuracy. Then we have false negative rate. We can calculate. Then F measure. This is it takes precision and recall both. So that we can say that this is a bit unbiased than recall and precision. So F measure, whenever we say classifier, if the F measure is good, then we can say it is good in terms of recall and also precision. In both ways, it is good because it takes the harmonic mean of recall and precision. Now, one thing left here, the thing is that in many cases, if the data sample is not, say you can say normally distributed, in many cases, it's not normally distributed. So if we use this parametric test, then the researchers doesn't accept the work. For that, they want some non-parametric test, because whenever we have say the data and the data is not normally distributed, then we need to have some non-parametric test. The example of the more non-parametric test is Friedman test, Wilcoxian rank sum method. Using those methods, we can do certain kind of say non-parametric test. In non-parametric test, what actually we do? We actually reject the null hypothesis with the small value of p. So what is the null hypothesis? Null hypothesis says that there are two models, model A and model B. It says that there is no difference between model A and model B. By the experimentation, you have to show that this null hypothesis is not true. Means if we have model A and a model B, and if you want to show that model B is better than model A, then the null hypothesis has to be rejected. Only then we can say the model B is not similar, same as model A. So many cases, actually, this non-parametric test is required. Now, my endeavor is to show one of the machine learning method, techniques, that is a decision tree, and using decision tree, how we can solve one's medical problem. Just going to that. Here the decision tree. What is decision tree? It's a tree-like tree. So if we do using decision tree, what is the benefit? So whenever we make a decision using a decision tree, the decision is transparent in nature, means we can see how the decision is made. For an example, if you talk about neural network, it can produce one decision, either 0, 1, or some classification or some regression values, but you don't know how the decision is taken, what are the things going on. That's why neural network is called black box in nature. They're a black box because you don't know the reason how the decision is taken. But the decision tree is a technique which produces a decision and in a transparent way. Because whenever some decision is taken based on some rules, and the rules are visible. This is interpretable. The human can understand if this is this, this is this, then we can say this is bad. Another question, what is the use of these transparent rules? The use of the transparent rules in many cases. For example, one I would like to give once a financial application. Nowadays, we can see that the loan applications, whenever somebody applies for a loan, whether the loan is accepted or rejected, nowadays it is done automatically. So we can train the model, we can give the parameters. If parameter matches, then we can say, yes, you are eligible for the loan. And doesn't match, then you are not eligible for the loan. That's not enough actually. In many countries, if the loan is rejected, then you must have convincing reason to the user. Otherwise, it can be a court case. So in that cases, you must have the transparent rules. This is that, this is that, this is that. Because your application doesn't match with this one, that's why you are rejected. So that decision is user convincing decision. This is one use. Another use that in machine learning, this is called actually compactness. Because whenever we divide some rule for the classifications, whenever some new pattern comes, we don't need to talk about the decision tree. We don't need to do the calculations. Just we need to see the rules. If rule matches, if this is that, then we can say this is that. So in say prediction, in testing, whenever some new pattern comes, the task becomes very much easier and very fast. By looking the rules, we can say this is the output is that. So this is in machine learning, it's called compactness. So it has the compactness facility. That's why decision tree is used in many cases. Now, how we can make a decision tree? That's the question now. So to make a decision tree, I'm going to make a decision tree with an example. This is the example. And now this example is called professor-student problem. So we have two classes, and the classes, one is a professor, another one is a student. And for that one, our objective is to make a decision tree. And then there can be a number of questions. I will clarify each and every question. And you can have any questions on that. I'll try to clarify. So now, if you want to make the decision tree from here, so we have to start with one attribute. Actually, what is the philosophy to make the decision tree? The philosophy is that if some attribute is having the highest discrimination ability to classify, that attribute should be chosen first. And if you do like that, then the tree becomes very reduced in depth and becomes very faster, and the accuracy of the tree becomes very reliable. So initially you don't have anything, just starting, then those questions we'll see. So initially start with the habit here. So habit is the first attribute, and now see the problem here, the habit. Habit is the attribute here. So here the attribute values. How many attribute values are there? Two values are there. Habit is quiet or Gabby, right? Two values are there, Gabby and quiet. So now based on quiet and Gabby, the whole training sample, how many training sample we have here? T1, T2, up to T8. We have 8 training sample, so we can partition. So here, if you partition, we can see that in Gabby, we have T1, T2, T3, T5, T7. And here we have T4, T6, and T8. Now, habit is already exhausted. So now habit cannot be taken. So habit cannot be taken. So how many are left now? Eats and food were left. So we can take any one of them. So we're checking here the eats. So it's how many values are there in eats? It's have 3 values: baked, roasted, and fried. So based on this baked, fried, and roasted, we have to now categorize this one. So now if you categorize out of this pattern, this set, it was baked. And we can say T1 and T3. This is T1 baked, T3 also baked. Right? It comes here. But again, fortunately, we can see the class of this T1 and T3 both are same. If they come to the same class, then the node can be labeled by the class as they belong to student. That's why this class is a student here. Similarly, if we see roasted, then we can see out of these patterns, T2 is having roasted. There is only one pattern. The class of the pattern is process. profession. That's why this node is labeled as professor. Now, if you see here, we have two attributes, T5 and T7. But keep in mind, their classes are different. So still, this process is not exhausted here in this node. Now, look in this node. In this node, in the similar way, if we broken down, that it can be broken in that way. T6 bit, that's why student. If you see here, we don't have any patterns, right? The roster can be, but we don't have any patterns. So it is rejected. This is rejected, right? So now we can make certain kind of policies here so that some pattern comes here, the test pattern comes here, we can classify it either professor or student. So keep in mind, if somebody wants to do work research in say decision tree, they can think about that. How, if this kind of problem arises, how this one can be resolved. So now here in the NPhard, we can see that in NPhard we have T4 and T8 here. So now the class of T4 and T8, they are not same, they are different. That's why still the process is not exhausted here. Now if you do here, as I said, exhausted footwear, now because one is left only, already we have exhausted, which one? Habit and it. So we cannot take now habit and it. Now this is the footwear. So if you say participant footwear, then we can find this was T5. T5 has a student and T7 professor. Now it's similarly here. So using footwear, if we partition, then we can say clocks, and it is labeled as student. You can see here T8 student. So that's why this is student. And T4 you can see here, this is professor. So in that way, the decision tree can be made. Now from this problem, we can make number of decision trees. So another decision tree we can have. So we have taken here habit. We have taken here footwear. Earlier what we had it. Just we change the combination. We change the combination. We change the order. Whenever we change the order of the attributes, we get different decision tree. So this is another decision tree. Now this is another decision tree. This is another decision tree. Another. How many we get up here? We're looking 8 decision trees. Just I made 8 decision trees, but keep in mind we can make more than 8 decision trees. Now, if we have 8 decision trees and if we classify some training pattern or recall pattern, then what is the problem? So these are the recall pattern R2, R1, R2, R3, R4. So we had how many decision trees? 8 decision trees. Now, if we classify that using those decision trees, then we can see that whenever we have say, R1 patterns, so all the decision tree classify them in this pattern R1 as a student. But R2, some of the decision tree classify this R2 as a professor and some rejected. And here R3, some of them assign them as a student and some professors. And R4, some assign them as students, some professors. So whenever we have a problem, if we don't have a unified way to make the decision tree, then we can make different kind of decision trees. So that we cannot have a unified result. So different people will make different trees and different kind of outputs we can produce and different kind of accuracies we can get. So if we mix arbitrarily by taking the values, so then this is not the right one justified. So we have to find some way, some order of the attributes. So this order of the attributes should be unified for this problem. For that one, actually, what do we need to consider? We need to consider the attribute which is having the most discrimination ability. That attribute should be chosen first and should be experimented first. Now in say decision tree, this discrimination ability is found using a ratio of information gain. Now this ratio of information, we need to find the ratio of information gain of each attribute, and we need to take the attribute for which the ratio of information gain is highest. Now to calculate this ratio of information gain, first of all, we need to calculate gain in informations due to the attribute. Then we can find the split informations, then make the ratio, then we can find the ratio of information gain. So initially we're talking about gain in information, how we can find the gain in information for a particular attribute. Before discussing the mathematical part, the philosophical part I'm going to discuss with this example, right? Now say we are having one training set. The training set is V0. In this training set, we have T1, T2 up to T8. Now we need to find how much or the information required to classify a training pattern into one of the classes. We need to find that information, and that information is called entropy of set V0. We did not apply any attributes here. We need to find the entropy of set V0. So now say attribute A is applied here. So when attribute A is applied, this set is split into two sets, two subsets. The subsets are V1 and V2. Now similarly, now we need to calculate the information required to classify a pattern into one of the classes. That is called entropy of V1. Again, we can find the entropy of V2. When you sum this entropy together, then this entropy is called the entropy of attribute A for set V0. So it is believed whenever one set is split by an say attribute A, after splitting, the required information to classify the attribute into one of the classes should be less, because already one attribute is say expanded. Whenever one attribute is expanded, some kind of information gain is there, so that the information required to classify one of the pattern to one of the classes should be less. So here, this is the entropy of the attribute A0. This should be less than this one. This should be lesser than this one. This is the entropy of set V0. Now, if you find the gain in information for attribute A, this one can be found by the difference between this minus this minus this. It means what? Entropy of set V0 minus entropy of attribute A for set V0. So the value whatever we'll get, that one would be the gain in information due to attribute A. So here the objective is to maximize the gain in information for the attributes. Now, how we can calculate the attribute? We talk about the entropy, all those things, but how we can find the entropy of V0? Now, there's the question. Now, here we need to find initial. These are the nomenclatures. We have m number of classes. In this problem, value of m is 2, and all the nomenclature, the description of the nomenclature are given here, and using all those descriptions here, we have a probability. And this probability is talking about what is the probability that a pattern in set V0 belongs to class CK. And this probability is called prior probability. This is called prior probability, right? So if we talk about the class P, out of this set, the prior probability becomes 3 by 8. Because how many we have, Professor? 1, 2, and 3. Out of how many? Out of 8. So the prior would be 3 by 8. That is called prior probability, right? Now the question is, if the prior probability is less than the information required to classify a pattern in V0 into one of the classes CK is more actually. If the prior probability is less, then the information required to classify that pattern in one of the classes is more, obviously, because the prior probability is less here. So if this is less, this should be more. Then how we can do that one? Simply by negative log. We know that the negative logarithmic nature of negative logarithmic is reverse in nature. If this is high, then this becomes low. So here the information required to classify a pattern into which class? Into class CK. Into class CK. We can find using this one. So our individual here is here to classify a pattern into one of the classes. So how many classes we're having? We're having m number of classes. So this kind of required information is required for m classes. This total one is called average information required to classify a pattern offset V0 into one of the classes m. Now, if we take the whole all the calculation together, now this one becomes the whole equations. And this is actually called entropy of V0. Entropy of set V0. So we get the entropy here. Now our objective is to find the entropy of attribute here. So the entropy now, initially we have to find the entropy of V1. A similar calculation can be applied here. So as in this problem, A1 is attribute. A1 divides the set into two sets, V1 and V2. So how many splits we have? 2 splits. So here n is 2 only. So we need to calculate 2, 1 and 2, and summation is there. And then we define this term as entropy of attribute A for set V0. So now these equations, if we elaborate, this equation can be represented by this one. So now we got the entropy of V0, we got the entropy of attribute A for set V0. Now we can find easily gaining informations for attribute A. So here the gaining informations, that is GA V0, and now entropy minus entropy of the set V0 minus entropy of attribute A for set V0, right? So now what is the objective? It becomes a maximization problem now. So objective is to maximize this gain in information. Maximize. How we can maximize? This is constant. We cannot change the entropy of the set. We can change only this one. What should be our objective? Our objective should be we should make it very much low. If it is very much low, very minimum, then we can say the gain is higher than the highest. So here the objective is to make this one low. So now for that one, if initially how many attributes we had have been each footwear, now say we have taken another attribute, that is name of the training patterns. It's T1, T2, T3, T4. How many? T8. Now say this pattern, this pattern, name pattern is say experimented here or expanded here. So if we expand this one, then how many steps will create? 8 steps. I have given here 6 due to paucity of space here. So 1, 2, 3, 4, 5, 6, 7, 8, 8 steps. And in each set, we'll have only one pattern. And the one pattern is having one class. So all the patterns are classified. All the patterns are classified. All the patterns are classified. So now the required informations to classify the patterns into one of the classes becomes 0. This is 0. 0, right? If we keep the values here, we can see that it becomes 0. The value of this one becomes 0. Or directly you can see here, because it is talking about how much information is required to classify one of the pattern to one of the classes. So already the pattern is classified. So the required information is 0. 0 plus 0, 0, 0, all are 0. So this is 0. So now if we have an attribute and it splits the set in number of subsets, then the gain increases. If gain increases, it's good, but it's a kind of bias. Why is a kind of bias? Because whenever one tree is made using this name of the training patterns, none of the value is common. So whenever some test pattern will come, the test pattern cannot be classified into one of them because there is no common values. Because whenever one test pattern will come, the name of the test pattern would be T9, T10, T11, to T12. So those patterns cannot be classified in any one of the sets. So maximizing this one and minimizing this one. So again, some biasness introduces here. So now to overcome from this bias, we have something that is called split informations. So if the attribute splits the set into number of subsets, then the split information becomes higher. So whenever we get this split informations, using this split information, the whole gaining informations can be divided. So if this one is less, then this one is more. If this one is more, this one less means what? It is maximized here. And if this one is less, this one is more. So somehow it balances. Somehow, because it is now divided by this split information. Now the question, how to calculate this split information? Simply by prime probability, then information required to extract the set Vj from V0 using these equations. I'm going a bit fast because I don't have time and I have to show one example. So this one, right? And then we can find, if we have say 8 number of sets, then we have to find the split information for all the sets. So for all the sets, we can find this is the split information here. This is the split information. Now using this split information, we can divide and we can find as a ratio now, and this ratio is called the ratio of information gain. This is the ratio of information gain, right? And finally the equation can be written like this. So we have this problem. Now we calculate the values because we had the problem earlier, and we make number of trees. If we make number of trees, then this is not acceptable. So to make one unified tree, so for that one, we need to calculate the ratio of information gain for each attribute. So here, the first one, the entropy is calculated. All the values are available here, right? From here, we have taken, and this is the entropy. And now, so after finding the entropy, we need to find the ratio of information gain for each attribute. So initially, we have taken habit. For habit, we need to find the gain in information for the habit. This is the gain of in information. Then this is the split information. So now we are having all the information available for habit. So now find the ratio of information gain for the habit. And we found that the ratio of information gain for the habit is this one, 0.0047. And now for this, if the value is this, the ratio of information gain 0.3233. Now for this one, footwear, the value is 0.3640. This is the value. Then this is the ratio of information gain. So now we've got the ratio of information gain for all 3 attributes which are available in the problem. So out of 3, habit, eats, and footwear, which one is the highest? Footwear is the highest. So now we have taken footwear first. This is footwear. Now the footwear is having two values. Already we talked about the clogs and sandals. So using clogs, we categorize it. And we found that footwear equals to clogs. How many attributes? 3 attributes. These are T1, T5, T8. And all they belong to same class. This is a student. That's why this node is labeled as a student now. And here now comes here the sandals, and we're looking at T2, T3, T4, T6, T8, and they are not in the same class. They are in, some are in the student, some are in the professor. So still, this node doesn't complete its process. So now we have to now again expand. Now we need to see the attributes. Which attribute is having highest the ratio of information gain here? Already footwear is expanded. So now in the next endeavor, this footwear cannot be taken. Just we need to explore only habit and its now. So now coming with the habit and its. So now, and keep in mind, now the V0 is this one. Keep in mind, now we're doing the process here. That's why V0 becomes this. So if we do the experimentation, now we get the ratio of information gain for its, and this becomes 0.6377. This is the ratio of information gain for the its attribute. Now find for a habit. The habit, the value is 0.0208. So out of 2, which one is the greatest? No doubtly, so it is the highest. So now we can expand its here. So if we see the its out of these patterns, which patterns? T2, T3, T4, T6, T7, then we can see that T3 and T6, their value is bet, and they have the same class. That's why they classify to student. And here we have a pride only, and its pride. 2 attributes are 2 patterns are there. T4 and T7, and their class is same. That's why it is labeled as professor. And now, if you see the value roasted, there is only one pattern, and that is T2, and its value is the professor. Now we can see all the patterns are classified. All the patterns are classified. So how many rules we can generate from here? Looking here. So how many rules from this decision tree? Just we need to have only 4 rules only. So using those 4 rules, in future, whatever patterns will come, we can classify. See, the first rule: if footwear is from this path, there is one rule, and that is what? If footwear equals to clogs, then the pattern class equals to student, right? And the second rule is what? Sandal, it is big, then this student. Third rule is what? Footwear, pride, then see professor. Then which one? Footwear sandals, and which one? It equals roasted, then the class is professor. Now I've seen that. If you see the depth of the tree, depth is only 2. So the tree is faster. In earlier cases, we have seen that most of the trees generated how many rules? 8 rules. But keep in mind here, how many rules we have generated? Only 4. So using 4 rules now, we don't need to have this tree now. We don't need to have all the calculations, because the calculations were used to fine-tune the model parameters. And here the model parameters is choosing the attributes. So we have chosen the attributes. So now we don't need to have the calculation part. We need to have only these rules. So using these rules, we can classify any pattern into professor or student. So now if we use these rules, on this is the recall pattern. These are the recall pattern actually, the test patterns. Now this test pattern can be classified easily. This one is student. You see here R1, the value is what? First one is the footwear. Clogs. Okay, it comes, yeah, if it is clogs, then it's students. So directly students. Here R2, footwear is sandals. If sandal comes here. And then which attribute? It is what? Roasted. Yeah, this is baked. No. This is fried. No. This is roasted. Yeah, this is professor. That's what professor. R3. Clogs comes here. And then which one? Then roasted. Which one is roasted? Here roasted. That's what. So which one roasted? Here clogs. If footwear equals to clogs, so directly it can be classified.
Dr. Sharot.
Just give me 5 minutes.
Time left?
Just give me 5 minutes. I can summarize.
Okay.
My objective is to show one application.
Sure.
So now already you have seen that this is the decision tree, and in that way we can make the decision. Now the question, how this decision tree can be applied on medical application. Here our objective is to find the risk factors for the diabetes. And this study is taken from, say, UCI repository. In the UCI repository, we have 8 attributes for the diabetes database. So X1, X2, X3, X4, X5, and these are the description of the attributes. And these are the corresponding classes. 1 means this is diabetes. The person is suffering from the diabetes. 0 means the person is not suffering from diabetes. Like that way, this is the description of the database. Now we're going to use the decision tree. You can have questions, but you have seen the decision tree. You have seen all the values were discrete, but here we have the continuous values. Yes, whenever we have some continuous values, there are some algorithms, discretization algorithm. Using those discretization algorithm, we can discretize the values. For that, we have entropy-based discretization, and we can have also vector quantization-based discretization algorithms. So using those algorithms, we can discretize the values and we can make the decision tree. If we make the decision tree for this one, we can have a decision tree. I'll show you. So here the main objective is to find the risk factors. Which risk factors is more responsible for diabetes disease? For that one, we made a simple model here. Simple model, it got published actually as a simple model. Initially, we take the data sets, then we generate the rules using the decision tree. Then we select the rules, then we prune the rules, then we merge the rules, then we find the major factors for the diabetes. Coming to that. So now this is the description of the data sets. So total number of patterns in the data set is 768. And in the Python, we did the coding. So this is the decision tree, which is generated in Python, and we use the version 4.5 decision tree. So this is the decision tree. Now, our objective now here, actually, we take only the positive cases because our objective is to find which are the parameters, which are the attributes which are responsible for diabetes. That's why we have taken only the positive rules, positive cases. So we did 10-fold cross validation. So from one training fold, this is the result. From one training fold. So from one training fold, we got 6 rules, and these rules are responsible for positive cases, which is diabetes cases. Now, from each of the sets, this is one of the training sets. So we have 10 training sets. So from the 10 fold, now from each fold, we have taken the best rule. So as we had 10, that's why how many we selected? 10 rules. This is from one fold, this is second fold, third, fourth, fifth, sixth, seventh, like that. Now the question, how we determine which one is the best? So we generally devise one equation here, and this equation is called SOR score, significance of the rule. And here the philosophy is that our objective is to make the transparent rule. Our objective is to find the risk factors. So if the rule length is less, then we can find the factors more easily. So the philosophy is here, if we have two rules, rule A and rule B, both are producing 90% accuracy. If the length of rule A is less, then the priority should be given to rule A. So that one is done by this equation. So this is only the accuracy of the rule. And here, the accuracy by rule length. Rule length becomes the denominator part. So whenever this one becomes bigger, then the score becomes lower. So if the rule length is less, we divide this one. When the rule length is less, then the score becomes higher. So in that way, we are finding the best accurate and more transparent rule actually from each set. So as we had the 10 sets, 10 folds, from the 10 folds, we got how many rules? 10 rules. 1, 2, 3, 4, 5, 6, 10 rules. These 10 rules are the initial rules. Now from these initial rules, we have to do pruning part. For pruning, what we did? We did sequential hill climbing backward selection search algorithm. So we drop one rule and looking whether performance increases or not. If performance increases, we permanently drop the rule, right? If not, then again we add and we can take the next rule. In that way, this is sequential hill climbing algorithms, the backward search. So we did the rule pruning part, and finally we got here 4 rules. Rule 1, rule 2, rule 3, and rule 4. Now we have 4 rules. And if we carefully see the rules, in the rule we have only 2 parameters actually with different ranges. We have only 6, x2, and x6 with different ranges. Now our objective is rule merging. How can we merge the rules? Because we had x2 and x6. Now again, what we did actually, we did sequential search. We dropped the range one by one, and looking that for dropping which this range of the attribute increases the performance of the system. So we got one range for x2. Similarly, got one range for x6. And finally, we got one transparent rule. This rule, whenever this condition happens, then we can say the class 1 is the person is suffering from diabetes. But our objective is to find the risk factors. Which one is the high? Which are the risk factors, and how much risk is associated with each factor. That's our consideration. That's why we take individually this parameter, these attributes with the ranges, individually with the ranges, because if this range is there, then these are the possibility that the person is suffering from diabetes. So what actually we did, we reversed the range. And looking that if the range can be controlled or can be managed for this attribute, then how much amount of or in what percentage we can prevent or manage the diabetes. So we did so reverse this range, the condition is reversed, and we took here the test accuracies from each horse. And finally, we have seen that if we control X2, the accuracy is 64. And only X6, then the accuracy is 82. So from X2 and X6, it is clear that this X2 is the major factor. If we can control this X6, then the 82% chance is there to prevent the disease. Now, if you combine, if somebody wants to control both of them, then we've seen that the disease can be managed up to 91.04%. So finally, this is the table here. So if this one, then this percentage. If this were both together, then this percentage. Now we denormalize the values. These are the normalized values, right? So when we denormalize, we get the value of X2 as 126.5 and X6 is 29.85. So if somebody can keep this X2 lower than 127.5, then the risk associated with this diabetes less, means that there won't be, say, diabetes, the possibility is 82.45%. And then this X2 attribute is talking about the glucose level. You can see that in the data set. In the data set, it is written X2 is the glucose. Yeah, this is glucose. The blood, sorry, which one? Glucose level. So if the glucose level we can keep beyond, it's less than 127.5, then there is a chance that you can manage the disease 82%. And if, say, this one is BMI level, the BMI index, this BMI index, and after denormalization, the value of the BMI index is 29.85. So here it can be concluded if you can say control this glucose level, this, and the BMI level, this, then there is a possibility that you can manage the diabetes up to 91%. So here just my endeavor is to show one of the example in medical example how the data science can be used or the machine learning can be used. So here now we can have a number of works because these are the values, these are the ranges. Now these ranges can be optimized using some optimization algorithms or the search, because in the hill climbing we use the sequential search. We can change it. We can use the floating search. So whenever we use the floating search, obviously the accuracy will improve. And here also, if optimization algorithm is applied, the range can be optimized so that accuracy, there is a chance that accuracy can be improved. So that's it. So using, say, this one machine learning tool. So here the endeavor is to show how, say in biomedical engineering it can be applied. So here we have seen how we can find the risk factors using, say, data science or even some machine learning. Thank you. You can have questions. I'm ready to answer the questions, whatever you have. I'll try my level best. You can put any questions.
Okay,
Thank you.
Saroj.
Yeah.
Dr. Saroj, I will share now some question answers.
Yeah,
so I will do the sharing. You can take one by one questions.
Thank you.
Okay, just a minute. So can you see the list of questions, Saroj?
Still not visible.
Is it visible now?
No, sir, not visible, sir. You can read out, right?
Okay, hold on. Now?
Sir, you read, then it's better, I think.
Is it visible now?
Yeah,
no?
Visible. Yeah. This first question is yes. There is no problem.
Okay.
Yeah, this is optimization. Keep in mind, I would like to add one thing. In machine learning, whatever techniques we have, whatever tool we have, all are somewhat maximization and minimization. You can tell me anything. I can show you the main function. Because every classifier depends on some function, and the function is associated with either minimization or maximization. Then, sir, next question. Autonomous car have, sir, my relevant questions, machine learning and data science, you can give me. Autonomous cars have used transfer learning to enhance the identification of the objects. Can we say this is learning based in biomedical engineering? Yeah, that first of all, I would like to tell you what is actually transfer learning. The concept, yeah, transfer learning. Yeah, nowadays the concept of transfer learning is used. So the question is, can we also see this method for learning being used in the bio? Yeah, it can be used, right? Transfer learning can be used. Use. Yeah. It totally depends on the applications, right? You can have a different kind of applications based on that you can use. It can be. Next question, so third question, what is difference between feature extraction, feature selection? What method for getting the feature should be preferred? So the first question, what is the difference feature extraction and feature selection? Especially feature extraction is used in image processing of the signal data. We are having the data, we're trying to make certain kind of features from there. Then we can say this method is called, this method is feature extraction. Or this is one example. Or another way we can say we can have number of features. For an example, 1 to 10. Feature number 1, feature number 2, feature number 3, up to feature number 10. Now somehow, so we want to change radically the whole features from that domain to another domain, right? Just we want to keep certain kind of, say, primary factors or primary kind of informations. For an example, PCA, principal component analysis. We can have a data set, 10, we can have 10, 20 attributes. Whenever we apply, that we can get 3, 4, 5, based on the rank of the matrix. We can get very small number of features. That method is called feature extraction. When all the features are extracted, now all the extracted features may not be useful for the classification. Then out of those extracted features, we can select which features is more useful. Then feature selection can be used. And now which one should be preferred? I'm telling one thing. Initially, I'll talk about the approaches. There are two approaches of feature selection. One is called filter method and another one is called wrapper method. So if you look for the wrapper method, then obviously floating search algorithm is the best. And now if we talk about the filter method, for filter method, the best and the state of art are relief. You can note down relief, or relief F, Fisher is 4. Now there is a component, a floating method. In floating method, there are two kinds of techniques. One is called forward floating, and another one is called floating backward method. So if you have 100 features and your objective is to select only 5 to 10, then you look for forward floating search, because here it starts from the empty set. Takes one, then it takes second one, takes third one, like that. In that case, you need to use the forward floating search. And if your having 20, and objective is to select a 16 out of 20. Most of the features you want to keep. So in that case, actually, you can use floating backward, because backward it starts from the whole set. It drops once, checks accuracy. Drops one, checks accuracy. So in that sense, if you use in that cases a floating backward selection, then your algorithm becomes more fast and then robust, I think. So that's it. And the next question, which one? Any questions, sir? You can, yeah. Which one?
My question, yeah. Next question. Does machine learning involve?
Yeah. Is the purpose of undersampling and oversampling gives the same results? To some extent. I'm telling, if the database size is very small, then you need to do oversampling. And if the database size is very huge, then you need to do undersampling. You can do, because I'm telling one thing. Whenever we apply any classifier to data, the objective is to generalize the regularities or the information whichever is there. So if we have more number of patterns, then we can take the generalizations more appropriately. So if the database size is small, and if you apply undersampling, so you are discarding the information from there. So the performance of the say classifier can be degraded. In such cases, we need to use oversampling. But anyway, both are applicable, but keep in mind, if you are the people who means the researcher of machine learning, and you are doing your experimentation with the data sets which are available in the UCI repository or the Hill repository, you should do oversampling, because the size is not very huge. There are some database. There are some database whose size is very huge, but what I prefer if there is an imbalance problem in my data set, I do oversampling generally. I do. Then, sir, next question, which one? What is deep learning and how does it contact? Yeah, yes. Deep learning is, you must have the knowledge of, say, artificial neural networks, right? In artificial neural networks, generally it is assumed that we are adding number of layers. But keep in mind, at the same time, the activation function and the learning functions are different. So learning functions are defined in such a way so that you will get higher accuracy. For an example, if you do, say, reinforcement learning, then you need to use deep belief neural network. This is deep learning. Example of deep learning. Deep belief neural network is nothing. If you stack number of random Boltzmann machine one after another, then we can make a deep belief neural network. That is deep learning. That is deep learning. This is one case. And another case, if you talk about a convolution, if you are the user or if you are the researcher of, say, image processing, then I'm telling you, you read mathematical foundation of convolutional neural network. No one can defeat convolutional neural network in image processing. But keep in mind, some people are using convolutional neural network in different cases. But I feel, so according to mathematical formulation of the convolutional neural network, if we apply in some other applications, the result may not be optimal. I think it may not be better. People are reporting better results. But if you see the foundations, because you must have one filter. This filter is specially designed to extract the image features actually. So deep learning is machine learning. So if you do research in image processing, please you see convolutional neural network, and different kind of nets are evolving. Google net and different kind of nets are there, and you have to apply the state-of-art net in, say, convolutional neural network. Nowadays, people say this is deep convolutional neural network. So you can use that one. So deep learning is machine learning. This machine learning, a big machine learning. Sir, any question?
Next question, I think, Saroj.
Yes, which one?
For a person with biology background, what should be approach to learn practical demonstration for techniques in AI?
So initially, you should start with some data science kind of thing, right? Data science. So you can get many tutorials in, say, available in, say, Google also, YouTube also. And especially if you want to work in biology background, there is a hot field that is called biochem informatics. How to design drug using machine learning or AI tools. There is a story, I'm telling you one thing, and you need to understand the machine learning algorithms. Because nowadays, in, say, COVID-19, there is a project also, because we did not have, say, exposure and expertise of biology. That's why we did not do anything. So in drug design, one part is there called drug repurposing. The drugs are actually invented in trial. It takes a lot of time. So some drugs are available. So I'm not talking this one. So you need to study the classification algorithm, and gradually you can understand. Whenever you study classification algorithm, you can understand very easily. Then sir,
next question is learning Python enough to learn AI and ML for use in biotech?
No, not for that. Not for biotech. Not for that. So in the Python, what you learn actually, Python, you have a basic programming language initially, like a C programming language. Python is a programming language. MATLAB is not a programming language, but Python is a programming language. You have number of tools. You have GUI based programming as a platform there. So during Python learning, when you study conventional and standard, you know what is function is there, arrays, different kind of list, tuples, this kind of knowledge you are having available. Then if you study some book, this one say Python for machine learning and AI, if you study in that book, actually you can get some of the information about AI and the machine learning. But keep in mind, if you directly use the tool, you won't have any mathematical foundation for that. So if you don't have any mathematical foundation, you cannot say I'm the machine learning researcher, I'm the data scientist researcher. You are the engineer, right? You are the you can say user of the machine learning tool and AI. So you have to study. If you study, I'm sure that you can have different kind of exposure. So you have to study, not the user only, right?
Okay. Next question is, can you give some examples on areas of ML is working hand in hand with biotechnology?
EEG recognition. That's an there is EEG recognition. This is done using ML technique actually.
Okay. Next question is, could you give us instances where AI and ML is being used in biological sciences, especially for people who are not for computer science background?
I told you this is drug design. This is my interesting area. If somebody is interested, they can come with me. Drug design. In drug design, drug repurposing is one objective. Then optimizations of the chemical is another aspect. Is how we can optimize the compounds to make a medicine, a drug. That can be.
Okay. Next question is how to collect data set in medical image processing.
Yeah, you, Rajendra, you know very well. So there is no answer for that one. You must have tied up with some research lab or initially for the experimentations to make yourself matured. You can take some data. So from kill library, kill data sets, or there are some other data, Kaggle data sets, you can get some image database. We do generally diabetic retinopathy for the eyes. One of my students is doing research on that. She is doing PhD. We have also published some papers. So initially you can image data from there. You can do the experimentation, and later when you become so mature and you want to do some kind of real research, you can collaborate with some research lab. That is it.
Okay. Next question is, can mathematical model be one effective way for data interpretation in machine learning?
Already I told you that. If you have, say, a mathematical model is really for data interpretation, because for model selection, most of people we do are use neural network. Not the way. So then in mathematics, actually, in using mathematical model, you can find the mean, variance, mode, standard deviations, and you can analyze the data. So you can interpret the data, whether the behavior of the data is scattered or something else kind of thing, so that you can select the models. So mathematical modeling is the main thing. Whatever in actually machine learning, mathematical modeling is the main thing. But using mathematical modeling, you can do data interpretation, data visualizations, whatever it is. Because if you talk about a histogram, it's a data visualization tool. So mathematical modeling is there, boss. So you can make some kind of different tools there so that the visualization can be more better. You can do.
Okay. Next question is, in a classification model, the pipeline that you have shared is a standard one, or we can alter it based on our data set. Also, can we increase parameters in pre-processing step?
Yeah, you can increase in pre-processing step. You can increase if you want, but I'm telling one thing: every classifier is having certain kind of capability. For an example, so in decision tree there is a chapter. With missing values, how the decision tree can learn. So if some missing value is there, so still the decision tree can learn. Similarly, the neural network can learn. But keep in mind, if we do this missing value treatment beforehand with some specialized technique, then the system becomes more robust. And whatever I have shown you, it can be a standard one actually. So you can omit something. So if you want the data cleaning part, if you want to omit, so you can omit it. There is no problem. But whatever I have shown you, I think, as per my knowledge, this is the best practice. And for this one, validation part, the tenfold cross validation, it is only accepted, otherwise not accepted. Because I cannot tell you all the instances here due to paucity of time. I don't have sufficient time. So I cannot explain one by one. You gave me one.
The last question, Saroj, maybe we can take. How supervised, unsupervised, and reinforcement learning in ML plays role in biological sciences? Which one is widely used?
Actually, I'm not technological background, so it's very difficult for me. But still, I can say. So unsupervised learning is very much used there, because the main objective is to find the patterns. What are the regularities are there? What kind of thing is there? This is one aspect. But also we can say supervised learning also, because any kind of medical diagnosis, whether some tumor is say cancerous or not, so it also belongs to biotechnological science, biotechnological study. So whenever we have the classifications problem, somebody is suffering from say COVID or not, using CT scan we can do. Somebody is suffering from lung disease or not, we can take the images from there. So in that case, we can supervised learning can be used also, and unsupervised learning can be used also. So till now, I have seen unsupervised learning, unsupervised learning, but I did not see the use of reinforcement learning in biomedical science or biotechnology.
Okay, so Dr. Saroj, a fantastic session, because I can see the feedback in YouTube. It is fantastic feedback that we have received from the participants, and it was really an interesting session. I was also listening the entire session. It was fantastic. So thank you very much, Dr. Saroj, for sparing your valuable time and giving an effort here to make people understand so nicely and easily the background of machine learning. For those participants who are basically from biology background in our workshop, most of them are from biological sciences, chemical sciences, and biotechnology, who have no background at all in machine learning maybe. So it was a very lucid explanation. Fantastic session. Thank you very much from the organization and on behalf of NIT Silchar. Thank you very much, Dr. Saroj.
Thank you, Rajiv, for your encouraging words. Thank you very much. Thank you, everybody. Thank you, participants. Thank you.
Thank you. So, dear participants, we are now signing off for the first half session, and please rejoin again at 2:30 p.m. For the next session, which is on big data to diagnosis. So that session will be by Dr. Animesh Acharji from Omics Marker Limited, United Kingdom, from Birmingham. I hope that will be a very interesting session, because Dr. Animesh works on metabolism and metabolics data, and he will show that how those data can be used and data science can be used for diagnosis purpose. So we are signing off now, and we will rejoin again at 2:30. Hope to see you again at 2:30 p.m. Thank you very much.